Question 2 is a rates of reaction question, and we're told about this equation, this reaction between benzene diazonium chloride and water, forming phenol, nitrogen and HCl. So the student investigates the rates and plots the graph of concentration of benzene diazonium chloride against time. And the first part of the question's asking for the definition of half-life. So that's the time for the concentration of a reactant to fall or decrease by half. Confirm the order of reaction with respect to C6H5N2Cl. So what we need to do here, when we've got a graph like this, a concentration time graph, the first thing we can do is, we could work out the half-life. So we're going to do that. So you can see I've calculated 2 half-lives. I've started with a concentration of 5 and gone down to 2.5 and found out how long has that taken, and it's taken approximately 54 seconds. I've then calculated a second half-life, so I've gone from 2.5 to 1.25. That's taken another 54 seconds, and so what we can say is the half-life is constant, and that is therefore first order. So there's my working out, first order, constant half-life, and then there's my 2 half-lives calculated, and that's what they were after for the marks. What will be the change, if any, on the half-life of doubling the initial concentration? Well, half-lives are constant, so there would be no change. And the students then predicted the rate equation looks like that. Using the graph and the rate equation, determine the rate after 40 seconds. Show you're working on the graph. So 40 seconds, what have we got to do? We've got to calculate the gradient at 40 seconds. So I've drawn a tangent, you can see that there. And to work out the gradient of that tangent, which is effectively the rate at that time, it's the change in y divided by the change in x. So my change in y is 5.2, my change in x was 117, so I'm coming out with 4.4 times 10 to the minus 2. And the units, well, this is concentration, this is seconds, so it's moles per decimeter cubed per second. And then the rate constant, so to calculate rate constant, if we divide the rate by the concentration, so how have I got that? Well, we've got the rate equation here. So rate equals K, rate constant, times the concentration. So if we get K on its own, the rate constant, that's rate over that. So we've just calculated the rate. So that was 4.4 times 10 to the minus 2, or whatever you got in there. And then the concentration is whatever it is at 40 seconds. So that's where my 3.4 came from. And we get a value of 1.3 times 10 to the minus 2. And the units, well, we've got rate, moles per decimeter cubed per second, divided by concentration, moles per decimeter cubed. You can see I've cancelled out like terms, top and bottom, and I'm left with seconds to the minus 1. So there's my units for K. The order of reaction with respect to water is effectively 0. Explain why. Well, we were told at the top of the question that the water is in excess. So if it's in excess, changing its concentration won't alter the rate. So you can't just say 0 order, you must say y. So it's 0 order because it's in excess.